Like I say, all these with just water, nothing's happening, but you put the ammonia in there, and you get an ink. You get something that stays together. The only downside of that is when you're printing, the pH is going to drop as the amines evaporate, and that's happening as you go through the ink train, but it's happening all the time. And once the pH evaporates, though, you do have a hard resin again. Now these resins, I didn't mention them on the pH. Resin is roughly a pH of about 4.5 to 5.5, somewhere in that range, these hard resins. And you hear them talk about on TV these floor waxes. They give you this nice, hard acrylic shine. They talk about very same kind of acrylic resins are in these hard. That's what gives them that hard coating on the floor. Well, you want that same protection on your ink. If you're looking for rub resistance, that type of thing, you need those fully cured resins to go back to a pH of like 4.5 to 5 for that ink to be totally what we call cured. It'll be dry to the touch. It goes through the dryers and all that, and the ink will be dry. It's not going to block up in the roll, but for it to be totally cured, you want those resins to go all the way back down to like that pH of 5, so they give you that protection that you're looking for. When the ink is printed, though, like I said, the downside is the ammonia evaporating takes some of the water with it, and as that's happening, that causes some of the problems, the most common problems with printing water-based inks. Several things happen as the pH drops. First thing, like we talked about, solubility decreases. When you're losing the pH, the amines are going out, it's trying to go back to rock and water. And you start getting dirty print on your process work, or fill in on reverses, that type of thing. The viscosity increases. Because the ammonia is evaporating, it takes the water with it. The ammonia and the water bind together. When the ammonia evaporates, it pulls water out with it. So you're losing water, so your vis is going to increase there. Also, the resins are starting to become a little bit tacky, and that's the one other reason that the vis starts going up. And because of the vis going up, then you get color shifts. Even if you're running Dr. Blades, and I'm guessing all you guys probably run Dr. Blades on everything, even if you're running Dr. Blades, the hydraulics of an ink, the thicker it gets, it's going to force that blade up a little bit more and let a little more ink go through. Two-roll system, it's a little worse than it is with a Dr. Blade. Then also, part of the other reason you get the color shift is these solids are trying to lump back together. It's trying to go back to rock and water. So part of your water's leaving, the vis is going up there, and then you've got your solids all trying to lump back together, so your color goes stronger and it gets darker on you, and you get color shifts. And then you get bad labels or whatever it is that you're printing, because your color's off. This is a little diagram of a typical ink train. You're asking the ink to do a lot of things here. The ink has to kind of walk a tightrope. You want it to stay wet, of course, in the fountain, on the ink roller, on the analox, so it can come around and get real wet. Then you've got the plate, and you want your ink to stay wet all the way up to that point, and then it goes to the impression cylinder onto the substrate. And then you've got, if you're running at 400 feet a minute, you've got a fraction of a second. That ink has to be dry before it gets to the next roller, or it's going to track. So, it has to stay wet all the way up the train on the rollers, but then you want it to dry within a fraction of a second before it gets to the next roller or the next station where you're going to put another color on top of it and trap. So that's the reason we have to use more than one resin to get a combination of these things to get them to do what we need them to do. Again, we go back to the pH, talking about that a little bit. When you start going below a pH of 8.8, that's when you start losing resolubility. Your solids are trying to lump back together, and you're going to get dirty print. Above 9.5, there's not much benefit to having a pH above 9.5. And if you get up around 10, you can start having problems with your equipment. You can have corrosion of the metal that's in the analoxes. If you ever chip the ends, everybody almost always, you chip the ceramic off the corner of an analox from handling it, and that high pH solution gets to that metal underneath there, and it can be corrosive. So, and also, it just takes it that much longer, like I say, to get back to this pH of 5. If you're going up to 10, it's just going to take longer for that ink to cure up and give you a full cure before it gets good and hard and gives you all the properties that you want it to have. We recommend a regimen of preventive maintenance. It's like anything else, your machines, your cars, you know, you have to do maintenance on them to keep them running. And it's easier to do a little bit of pH management or maintenance rather than wait until you've got bad print, you've got color shift showing up, and then you have to adjust it because it's going to take more of a change to get it back in line, as opposed to if you'd made maintenance adds of something like a pH adjuster as you ran the job. We manufacture several pH adjusters. They do several things. They maintain the pH level, they reduce the viscosity. The pH adjusters we use are, for the most part, they're mostly water. They're up to 70% water. But then they have the amines. They also, some of them have a little bit of an alcohol in the film pH adjuster we make. There's a little bit of defoamer in the paper pH adjuster. All it takes is about 1 to 3 ounces per gallon every 30 or 40 minutes. And 30 to 40 minutes is kind of the extreme. That's for like process printing, where you don't really have any ink takeoff and you're not putting any fresh ink in. For most people, maybe an hour or up to 2 hours is fairly typical for a real world press room run. Maybe every couple hours, hitting it with about 1 or 2% of this pH adjuster. All you're putting in is what's evaporating out. You're putting water and amine back in, and they've been evaporating out. So all you're doing is replacing what you're losing. So you're not hurting the color of the ink. You can use them to reduce the strength up to about 20%. If you need more color reduction than that, then you need to use an extender, because you're going to drop the vis too low, and then you start getting into mottled print and that type of stuff, and you don't want to do that. Plus your process dots don't do as good when you go too thin there. Our particular product is EC1552 paper pH adjuster. Just like we've talked about it, it's made for maintenance ads and paper inks. It's totally resin free. There's no resins in here, so your inks don't get tacky over long runs. We do have some refreshes for certain systems, and they have resins, the same kind of resin that's already in the ink system will be in the refresh. If somebody thins an ink out too much, you can put something like a refresh back in, has a little bit of resin to it, and it'll give the ink some body. It'll kind of body it back up a little bit again. But for long runs particularly, if you keep doing that, you can over-resinate an ink, and then you start getting a little bit of tackiness. So we came up with these pH adjusters, which are, like I say, is nothing but water and amine for the most part. It does contain a slow amine, and like I say, we'll talk about those a little bit later. It can slow the drying, and we don't recommend it for film inks particularly because of potential for blocking. We do have another one for film, and like I said before, it has just a little bit of alcohol in it to help the wet out and to keep the dry rate more in line with the fast dry rate that you usually have for film inks that you're running. Again, the very same formulation, water and amine. It is a different amine. It's a different dry rate of amine, a little faster drying amine, a little more volatile, and it has no slow solvents in it at all and no resins. It can be used on film or paper, but predominantly it's intended for film just because of the faster dry rate. Extender is nothing but clear ink. It has everything. Some people call them extenders, some companies call them transparent white. Same thing, it's nothing but ink. It has everything in it except the pigment. All the resins are there, the water, the amine, everything except the pigment. That's the only thing it's lacking. And you can use as much of that. The viscosity of our extender is going to be the same as the ink, so that's not going to change the viscosity. All you're doing there is using it to cut the color strength.